Myself, GSN sir. Today we are starting the DBMS exam series. For better understanding, we have used AI voiceover. This series is only for exam preparation purpose. So, make the most of this opportunity to score high marks in your exams. Let's begin.
In today's lesson, we will be discussing some fundamental concepts of DBMS. We will begin with the definition of data, followed by the definition of information. Then we will understand what a database is, explore the different types of databases, and learn about the core functions of a DBMS. Finally, we will look at the key differences between a traditional file system and a DBMS. Let's get started. What is data, and what is information? Are two fundamental concepts in the digital world. Think of it like this. Data is like the individual ingredients for a recipe. They're just raw components on their own. Information is the finished dish you make with those ingredients. It's the data that has been cooked up, organized, and presented in a way that's useful and has meaning. What is data? Data is a collection of raw facts, figures, or symbols in an unorganized form. It can include numbers, alphabets, images, or symbols. Data alone has no meaning until it is processed. It is a fundamental concept in computing. In the context of computers, data when processed it becomes information, and it will be stored and transmitted. Without data, a computer system cannot function. In next slides we will discuss in detail. Data becomes information when analyzed and placed in context, providing a basis for understanding, decision-making, and further analysis. Processed data is called information. Data must undergo a process to become valuable information. This process, often called data processing, involves several key steps. Collection, gathering raw data from various sources, e.g. surveys, sensors, user inputs. Preparation, cleaning and organizing the data. This involves removing duplicates, correcting errors, and formatting it for consistency. Analysis, applying various techniques and algorithms to find patterns, relationships, and trends within the data. This is where the raw numbers start to tell a story. Output and storage, presenting the processed data in a usable format, such as reports, charts, or dashboards. This information is then stored for future use and decision-making. A database is a carefully organized collection of structured information, or data, that is stored electronically. In today's digital world, almost every application we use relies on some form of database to keep information safe, accessible, and well organized. To manage these large volumes of data effectively, we use a database management system, often called a DBMS. A DBMS acts as an interface between the user and the data. It ensures that data is stored properly, retrieved efficiently, updated accurately, and kept secure from unauthorized access. One of the biggest advantages of a database is its ability to handle different types of information. It can store text, numbers, images, and many other formats, making it suitable for a wide variety of real-world applications. In everyday life, databases are all around us, even if we don't always notice them. For example, social media platforms use databases to store millions of user profiles, posts, messages, and interactions. Companies depend on databases to maintain customer records, track sales, manage inventory, and run their operations smoothly. Banks use highly secure databases to store customer account details, transaction histories, and financial information, ensuring accuracy and safety. In short, a database management system, or DBMS, is a software application that enables users and other software programs to create, manage, and interact with a database. Its primary function is to serve as an interface between the database and the end user or application, handling all data requests and operations. In simple terms, a DBMS helps store data safely, retrieve it quickly, and update it easily. It acts like a manager that controls how data is accessed, making sure everything runs smoothly and securely without any failure. A database is an organized, electronic collection of structured information or data. Data can be in various formats, including text, images, videos, and numbers. The structured nature of a database allows for efficient storage and retrieval of this data. In simple terms, a database helps store different types of information in a neat and organized way so that we can quickly find, update, and use the data whenever needed. Relational databases. These databases store data in a structured format using tables, which consist of rows and columns. They use SQL, structured query language, as the standard language for managing and querying data. Examples of relational DBMS include MySQL, Oracle, Microsoft SQL Server, PostgreSQL, and Snowflake. In simple terms, a relational database organizes information like an Excel sheet with tables, rows, and columns, making it easy to search, update, and manage data using SQL commands. NoSQL databases. These databases do not use the traditional table-based relational model. Instead, they store data in various formats like key-value pairs, documents, wide column, or graph structures. They are often used for handling large volumes of unstructured or semi-structured data. Examples of NoSQL DBMS: MongoDB, Cassandra, DynamoDB, and Redis. In simple terms, NoSQL databases are flexible and can store data in many different shapes, not just tables. They are great for big data, fast performance, and applications where the data doesn't fit neatly into rows and columns. DBMS is an intermediate layer between programs and data. It is a piece of software that provides services for accessing a database. DBMS helps in managing large amounts of data in an organized manner. That IT acts like a bridge between applications and the actual data stored in a database. Instead of allowing programs to directly handle raw data, the DBMS manages all interactions safely and efficiently. There are two general modes for data use: queries, transactions. Both of these forms use the DBMS for processing. The query is processed for presentation in views. The transaction is processed for updating values in the database variables. Core functions of a DBMS. A DBMS provides several key functionalities that simplify data management. Data definition allows you to define the structure of the database, including creating tables, specifying data types, and setting constraints. Data manipulation enables operations on the data itself, such as inserting new data, updating existing records, deleting data, and retrieving information through queries. Data security provides security measures to protect data from unauthorized access, including user authentication, access control, and data encryption. Data integrity ensures that the data is accurate and consistent through rules and constraints that prevent invalid data from being entered into the database. DBMS is a computerized record-keeping system. It is designed to manage and maintain records efficiently. It manages the database. The database is the information to be stored, and the DBMS is the system used to manage it. It supports different types of systems. DBMS can be used for small systems on PCs as well as huge systems on mainframes. Data use is handled through two modes: queries and transactions. Queries are for retrieving data, while transactions are for updating data. An application program interacts with the database via DBMS. The program sends requests, like in SQL statement, to the DBMS to perform actions on the database.